I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Monday, April 27th. Tonight we'll be discussing jet stream level winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean. Let's get to work. Looking at significant wave heights for the North Pacific Ocean, we see remnants of a gale off of Canada, pretty much moving inland there, but a small area of like 18-foot seas were generated, and another gale developing north of Hawaii with 21-foot seas and pushing off to the east. So the North Pacific is starting to awaken again, while the South Pacific is sound asleep. Let's get into the details. As usual, we'll start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they do form, help direct their track. We're in the South Pacific right now because it is the season when the South Pacific should be most active. It isn't. The North Pacific is, but still, we're going to review the Southern Hemi first. All right, so the core of the jet stream, the southern branch of the jet stream is depressed way far to the south, 70 south here. Here's Antarctica. The ice line is somewhere above 70 south, and here's the jet down here. So there's literally nothing going on. We're looking for a trough that is, the jet should be bending up to the north, sort of like it is here, but that's a cut-off trough. We want the main jet stream flow push off to the north. That would help create a clockwise flow aloft. That's the hallmark of low pressure in the southern hemisphere. Also, it would create that same circulation down at the ocean surface, and that is, it's low pressure, and if it's deep enough, that creates winds. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. So everything comes from the jet stream, hence that's why we're looking at it. All right, so nothing going on at the moment. Then we get into about Tuesday night. You notice there's still energy probably down into Antarctica, but the jet also is starting to build under New Zealand with winds to almost 130 knots and fading pretty quick, but moving more to the north up here at 55 south, okay? And there is the beginning of a little trough under New Zealand about midday Wednesday. That trough builds a little as we get into Thursday, and there we go, into Thursday night, almost looking like a legitimate trough being fed by 140 knot winds. Unfortunately, it gets kind of pinched off. That it means it's really tight right there. It's, just like a V going instead of more of a broader curve. That would provide a broader circulation, of course, for low pressure development. But anyway, you take what you can get. Looks like a bit of a trough starting to dig out as we get into Friday night and Saturday here. Kind of a mix of a cutoff trough, if you will, but still good area of winds in the 130, 140 knot range feeding up into it. So maybe something could develop from that as we get into Saturday. But then you notice everything's pretty much cut off, and this guy is all off by himself here. The cutoff troughs are not good for gale development. As we get into Sunday, that all washes out. Another trough starts building, though, on Monday, south of New Zealand. Not super well formed, but at least it's some hope. It's better than a ridge down at 70 south. So something to maybe look forward to in the Southern Hemi. All right, let's go take a look at surface level winds, surface level pressure. So here we are, and as expected, with the jet stream way down here, we're looking for any sort of a gale producing 35 knot winds over a decently broad area, and just nothing in play there. We're just going to click through this here. Now, here's a broad low pressure that starts setting up as we get into Wednesday, because we know there's sort of a broad weak trough organizing here. Nothing particularly interesting yet. But then as we get into Thursday night, notice 30, 35 knot winds, not strong enough really, but over a broad area named well to the northeast, continuing into Friday. And then remember how that trough was sort of semi-cut off. You can actually see the part of the jet falling south right here, the part of the jet pushing north here, and you get a sense of some sort of building gale here. I'll click away from it just for a second. There you go. You can see 40-knot winds pushing up to the north there in Friday, and then 45, almost 50-knot winds. And in fact, it is 50-knot winds into Saturday, and 55-knot winds Saturday morning right there, a little tiny area, and then backing off from 45 knots into Saturday night, and then fading as we get into Sunday, dissipating from there. Then there was another trough we saw down here south of New Zealand about that time, and you can actually see some building fetch in that area. Now, not strong enough, but at least some remote hope of something going on. All right, let's go take a look at the wave models, and they'll tell us what effect these winds have on the ocean surface. Here we go, significant wave heights for the South Pacific Ocean. Now, we don't expect to see anything. We're really looking for, at a minimum, we're lowering our standards. We'll say 27-foot seas, so that'd be, something in the bright red category over a decent size area. Don't really see that until we get into, here's the beginning of the trough in the central South Pacific. On Friday, there you go, 28-foot seas, building to 32, 34 foot, 37 foot according to this, over one tiny little area, building to 46 feet. Here, we'll click away so you can see that. Now, not a huge area, but aimed pretty well to the north, so that's a plus if you believe it. Continuing into 46 feet into like midday Saturday, and then Sunday the system starts fading out, but still in the Southern California swell window the whole time. Probably too far to the east for anything aimed at Hawaii, but certainly good for California, Mexico, down into Central and South America, if this were to materialize as forecast. Still a ways out on the model, so don't believe it yet, but there is some hope. Then a quick look at the northern hemisphere. So here's the Gulf of Alaska. This was Saturday night, 2 days ago. Little gale developed, 20-foot seas, something like that, barely in the northern California swell window there, mainly for the targeting, we'll say, British Columbia down into maybe Oregon or so. But then, as we get into Monday, a new gale starts developing north of Hawaii. And looking at the forecast, that gale is actually forecast to build relatively decently. 26-foot seas by tonight, and 27-foot seas overnight, continuing into about Tuesday morning, then heading off to the northeast, fading out, but still decent pulse of swell. You can actually see the leading edge of seas from that swell pushing into northern California later on Wednesday into Thursday. Another gale is forecast behind that, much weaker, tiny area of maybe 18-foot seas, and that too lifts to the north. Redevelops a little bit on early Saturday morning, 21-foot seas to 22-foot seas, 23-foot. So there is some hope there. There's an interesting kind of mix of, we'll get short-term maybe northern hemiswell, and longer-term some southern hemiswell. And then even more forecast behind that, if you believe it, getting into Monday with a small gale with 25-foot, 26-foot seas again in the Gulf, and another behind that, and maybe another behind that. So an interesting mix. It seems like the northern hemi is waking up, and the southern hemi might possibly be waking up as well. So then let's go take a look at wind swell potential for California, Hawaii. All right, so the standard deal here is we're moving into the summertime season. High pressure typically starts building in the Gulf of Alaska. Heat builds over the U.S. That creates low pressure, rising air over the deserts there. So you end up with low pressure inland, high pressure off the coast. When the two of those get close together, the isobars, these lines, tighten up, and that means stronger wind. That's sort of what we've been seeing. Steady northwest flow over the California coast. You really want it to be a little bit further to the north to generate wind swell. And relative to Hawaii, not a whole lot of fetch east of the island, since the high is more centered right up along California. Of course, you can see our building low pressure here in the Gulf of Alaska, but we're not going to get into that. So wind swell, it looks like it's going to start maybe Tuesday evening or so, but this gradient not super strong because there's this prevalence of low pressure just nonstop dipping through the Gulf of Alaska. So some form of weak short period wind swell for California. Trades start picking up for Hawaii as we get into Thursday, Friday, but the fetch area is pretty shallow. It's most of the winds start at the islands and then are west of there. But maybe For exposed east-facing shores, some degree of wind swell. That's about 300 miles of fetch. That's about as much as you get in California in the summer, too, with the north winds. We're into Sunday now, and still, yes, some fetch along the coast here. Very limited, though. Mainly from, we'll say, maybe Morro Bay southward. So not great for producing wind swell, but for California. But for Hawaii, notice this broad fetch of easterly winds as we get into, when was it? When did that start? Actually, there we go. Sometime, even into Saturday, the fetch started building. So better odds for wind swell for the Hawaiian Islands, exposed east-facing shores for the weekend, we'll say. All right, let's go take a look at any odds for precipitation. And we'll go through this pretty quick. The dividing line between California and Oregon is right there, and that's pretty much the precipitation line, too. We're just blasting through this quickly. No real, there we go. What was that, on Thursday night? Maybe some showers for Cape Mendocino area. Then there's another, here we go, this batch on Sunday. That's almost a week out. Forecast coming in associated with the front with the low pressure in the Gulf of Alaska. Maybe some snow in higher elevations of the northern Sierra Sunday night. And maybe, we'll say maybe into Tahoe, North Shore, maybe some snow flurries at night. And then that's it. Things dry out. I mean, we're pretty much over the ski season, even if backcountry skiing, I guess, that's still plenty much an option. But in terms of resorts, not a chance. Everything's locked down, and I think everyone's given up the ghost for now. All right, so what's going on long term with the Madden-Julian oscillation? And of course, El Nino or La Nina. As usual, we like to look at winds in what we call the Kelvin wave generation area, basically the far West Pacific. So this is the East Pacific here. This is the West Pacific here. That's New Guinea there. There's the equator, and there's the date line right there. The Kelvin wave generation area, the area that if you have the active phase of the MJO moving over it, and the MJO moves from west to east periodically, it's a continual pattern, taking about 3 weeks, let's say the active phase, 3 to 4 weeks to traverse the Pacific, moving from west to east on the equator, followed by the inactive phase. It takes its 3 or 4 weeks to go across, and then the active phase follows behind it. When in the active phase, trades get suppressed in the West Pacific in the Kelvin wave generation, that area from 170 west, 5 degrees north and south of the equator. If you get west anomalies in this area or significantly decreased trades, that can take warm water that normally pools up here, starts pushing it off to the east under the equator. About 3 to 4 months later, it can show up, erupt along the coast of Ecuador, and if you get successive Kelvin waves, which require successive active phases of the MJO, then that can be the start of El Nino. And of course, El Nino is great for surf production along the California coast and Hawaii if it's strong enough, and of course, if you're in the fall and winter months. All right, so right now, east winds, we're just looking at the arrows here, pretty strong over the entire equatorial Pacific, but it's anomalies. That's what we're really interested in, the difference from normal for this time of year. And you look at the arrows and you see, the winds are stronger out of the east because you see the arrows blowing a little bit out of the east, but then you get to the central Pacific and it's about normal. The arrows are pointing north or south, but no east or west component. But then you get into the Kelvin wave generation area to about 165 east, and trades are stronger than normal, just slightly, but then west of there, a little bit stronger out of the west. But there's only one arrow there, so maybe the date is a little bit suspect. Okay, let's go see what the forecast is. All right, so this is zonal wind anomalies, fancy words for what's the wind doing 4,700 feet up in the air, but that's a pretty good proxy for what's going on down at the surface. This is the whole planet on one chart. Date line is 180 west, okay? Kelvin wave generation area, and the far West Pacific start at about 135 east, so roughly there. And then the Pacific goes the whole way over to about 80 west on the equator. But Kelvin wave generation area just to 170 west. So we're looking straight up there and straight up here. This is past performance here. You can see the dates. The reds and yellows are westerly anomalies. So we had a westerly wind burst associated with the active phase of the MJO in early April. But then you see blues starting to develop easterly anomalies. Here's where we are today. The forecast not looking particularly good. Strong easterly anomalies forecast for the next 7 days. Westerly anomalies over the maritime continent. That's Bali, that area. Trying to make it into the far West Pacific, but not getting there this week at least. Let's go take a look 2 weeks out. All right, outgoing long-wave radiation. Another component of the MJO. It's basically cloud cover, right? Okay, the active phase of the MJO, when it traverses the Pacific, it's like a low-pressure system, basically. It has rain, it has clouds, and it has westerly winds associated with it. So this chart looks for amount of sunlight reflecting off the ocean surface. Negative anomalies, the blues, suggest more cloud cover than normal, less sunlight reflectivity. The reds and yellows, more sunlight reflectivity, high pressure. So that's basically the inactive phase of the MJO. This is the active phase of the MJO. This is today. I'm sorry. So there's the equator right there. Kelvin wave generation area, far West Pacific, so basically right around in there. So this, per the statistic model, inactive phase of the MJO, 5 days out, 10 days out, fading 15 days out, and the active phase starting to build in the far West Pacific. That per the statistic model. Now the dynamic model, the GEFS model, a little bit more positive, suggesting the inactive phase of the MJO fades about 10 days from now. And the active phase, not as strong. You can see, oh, here we go. Not as strong as the statistic model, but still the active phase making a little bit more progress into the far West Pacific at 15 days out, roughly 2 weeks from now. So the dynamic model is a little bit more favorable. Then phase diagrams, another way to sort of quantify exactly where the active phase would be and exactly how strong it is. All right, so assume you're looking down on the North Pole. The MJO travels around the equator from west to east over the Indian Ocean, maritime continent, to the West Pacific, East Pacific, under the United States on the equator, across the Atlantic, over North Africa, back to the Indian Ocean. The heavy dot here, look, is right there. That's where the active phase is. So it's basically in the Indian Ocean. The further the dot is away from this circle, the stronger it is. So it could be way out here, or it could be way in here, but it's modestly strong in the Indian Ocean. And these are the 3 forecast members from the statistic model, suggesting the active phase moving slowly east over the maritime continent 2 weeks from now, and basically pretty weak. The GEFS model, same deal, same position, and forecast making it maybe a little bit further into the West Pacific, but very weak at the same time. And so the two models are more or less in sync. Next up is the upper level model. This is like jet stream level. Just shows you the propensity for potential for precipitation. The greens, favorable for precipitation. The yellows, not favorable. The greens, basically a rough guesstimate of where the active phase of the MJ would be. And the yellows, the inactive phase. And this runs about a week ahead of what's really going on at the surface. So today, and there is South America. There's the equator right there. Dateline roughly down there. New Guinea, Philippines. You get the idea. All right, so inactive phase in the East Pacific Ocean, moving into and over Central America and gone by May 6th, with a weak active phase building behind it. We'll say early May, making its way across the Pacific through about the end of May, May 26th, and then another inactive phase building May 21st in the far West Pacific, and it making its way across the Pacific. The trend, generally all these phases of the MJO looking pretty weak. If anything, the current inactive phase that's working its way over the East Pacific is probably the strongest of anything for the next 40 days, at least according to this model. And then the CFS model, this going out a month. This is down at the surface, or actually 850 millibar, and this is winds, all right, rather than precipitation. Again, whole planet on one chart, Kelvin wave generation area from here to about here. Here's where we are today. Begin the forecast. The blues are east anomalies. You see east anomalies in control, building strong a week from now. This is the dotted contour is the inactive phase of the MJO. So it's interesting. The strong east anomalies are lagging behind the inactive phase. Inactive phase is supposed to be almost out of the Pacific when the east winds are the strongest in the Kelvin wave generation area. And then you go into, beyond that, kind of just a neutral MJO pattern. Yes, the active phase is supposed to set up behind. You can probably see it almost working its way across here, but very weak, one contour line, and all the west anomalies associated with it, mainly east of the Kelvin wave generation area, with some sort of generic neutral to easterly anomaly pattern continuing for the next month. And what that means is generally not very good. So why do we care about all this? Well, the active phase of the MJO helps push energy up into the jet stream. As we saw from previous charts, the jet stream is what drives the swell production machine. So if you have either a neutral MJO or an inactive MJO, it tends to dampen the transport of energy into the upper levels of the atmosphere to the jet stream, and therefore tends to not be particularly favorable for storm production. That does not mean, of course, that you don't get storms, but just there's not that extra bit of energy to really goose things up. Your storms tend to be short-lived. They tend to be smaller in fetch area. Their ability to produce swell tends to be less. You get weaker swells, less number of waves per set, and they're fewer and far between, and it's basically you walk away from a season during an inactive phase of the MJO and go, gosh, that was not particularly exciting. Yeah, there were waves, but nothing more. All right, let's move on. And then the 3-month CFS model. So this is the same deal, whole plan on one chart, Kelvin wave generation area from here to here, but past performance is on the bottom. The forecast is going up. You can see two major active phases of the MJO with westerly anomalies back in February and January. Since then, the pattern's been very weak. You can see easterly anomalies in the Kelvin wave generation area today. We're supposed to get a little bit of west anomalies, and that's supposed to continue. But notice as you get into June, you get this building pattern of easterly anomalies. Now they're not, the Kelvin wave generation area starts roughly right along there, that line there. And you see easterly anomalies encroaching in it, but mainly east of the Kelvin wave generation area. But our westerly anomaly wind pattern here is slowly retrograding west towards the maritime continent. So let's overlay the MJO. We'll start there. Oops, there we go. All right, so currently inactive, the dotted contour, inactive phase of the MJO. It's in control of the Kelvin wave generation area. Supposed to last about another week, but notice westerly anomalies start building ahead of this next active phase of the MJO. It's supposed to set up, we'll say March 5th and go through about the 21st of March, something like that. And then a week inactive phase behind that with just this mixed bag of east and westerly anomalies, nothing real solid. And an active phase behind that just never gets its act together. Finally, perhaps a decent active phase in June, but it too has westerly anomalies, but they're all west of the date line and never make it further than that. Notice these easterly anomalies here. All right, so then we overlay the low-pass filter. All right, so this is the solid contours like a low-pressure bias, the dotted contour like a high-pressure bias. And this is the patterns we've been in for almost 2 years, where you have this high-pressure blocking pattern in the Indian Ocean. It really, it's hard for storms to form in the Indian Ocean, and you have this low-pressure bias right smack over the Kelvin wave generation area. Now, last winter, you would have thought we would have had a good winter for storm generation given this pattern, but we didn't. And, you can't always explain everything by the charts. But if you thought it wasn't particularly good this past winter, well, look what's happening. The low pressure bias completely fades out. The high pressure bias here, what we've been hoping would not happen, is now hinting at on the charts with the high pressure bias forecast starting to build over the right around the date line and the East Pacific. And that is typically what, if this smells like El Nino, then this smells like La Nina. And this model has been consistently suggesting some sort of a La Nina pattern developing in the Pacific Ocean come about later in the summer. So, something to keep our eyes on. And with that, let's move past the MJO now and start looking at what's going on with El Nino, La Nina. The first place we're going to look at is in the ocean. All right, we're going to look at down in the ocean, ocean surface, and above the ocean. So, TAO buoy array, again, series of buoys strung across the equator used for monitoring El Nino, West Pacific there, East Pacific here. These are the anchor lines on the buoys. They're just like from 2 south to 2 north on the equator. And the X's are the sensors on those anchor lines. The data gets captured, beamed up to satellite, processed, add a model, you get a profile of subsurface temperatures. If you have El Nino, you have building warm water in the East Pacific. If you have La Nina, you have building cold water in the East Pacific, and all your warm water is in the far West Pacific. Today, the 30 degree isotherm, 30 degrees centigrade that is in the far West Pacific. It's pretty small. There's not a lot of heat energy in the Pacific. We've had this long-going, slow bleed like El Nino kind of pattern been going on for a couple of years now, and I think the Pacific is pretty much tapped out. The 29 degree isotherm holding. Well, it was at 180. It's actually backtracking. It's almost at 175 east now. 28 degree isotherm. Now, it was a brick wall at 160 west. It's actually pushing off to the east, suggesting it's some sort of Kelvin wave trying to push through the area. 24 degree isotherm. Not bad. Still plenty of warm water in the far East Pacific. So, nowhere close to La Nina at the moment. But it is the anomalies, differences from normal for this time of year that really tell the whole story. You can see warm water in the East Pacific here. This is Kelvin wave number 6 pushing into Ecuador and out of the picture. And there is a pool of warm water behind it, but nothing that clearly screams like at us saying Kelvin wave or El Nino or anything like that. It's just this generic sort of lukewarm pool of water that's maybe 1 degree centigrade above normal in a pocket, and it's getting shallower. You typically want to see this warm water going down to about 150 meters. Well, it's only 75 or 70 meters deep in the East Pacific, and underneath it, you have this persistent pool of cool water too. Sometimes it goes down to -3 degrees, and it seems to be making headway bulging up into this region, and the only thing that's holding it off is the last Kelvin wave pushing off to the east. We suspect there is no eastward momentum on any of this warming water, and our biggest concern is the Kelvin wave erupts off of Ecuador. This Kelvin wave number 6 erupts off of Ecuador, discharges, there's no Kelvin wave behind it, and this cool water just goes boom and explodes at the surface, and that would be a good sign of a developing La Nina. Now, the good news is it's almost May. It hasn't made it to the surface. The earlier in the year, like if you get something like this, a cold water eruption starting in February, you know you're in for a strong La Nina. The longer it holds off, that's probably the better. And it looks like we still have maybe 2 weeks, 3 weeks before anything happens. So we'll keep our eyes on that. Here's another model using the exact same data. It's a little bit more favorable in that here's our Kelvin wave. It looks like it's a little bit stronger. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 4 degree anomalies in +4 degree anomalies in one pocket. And the upwelling phase of the Kelvin wave cycle, this little patch of cooler water is all but gone. So this final Kelvin wave trying to erupt, and it's suggesting 1, 2, 3, a degree, maybe a degree and a half. I'd like to say this is a developing Kelvin wave, and you see there's plenty of warm water pushing off the maritime continent, falling into it. But we know there's no westerly anomalies and there's no momentum, so I suspect even if this were to quote-unquote form a Kelvin wave, that Kelvin wave isn't going to have much momentum and isn't going to make it very far east. Then, of course, our cool pool with 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, 3 to almost 4 degrees below normal as of April 23rd. We'll see. It's going to be interesting to see whether this guy makes it to the surface once this Kelvin wave erupts, or whether this warm water will hold its own and keep this cool pool suppressed. I mean, we just literally don't know. Sea level anomalies. This is JSON 3 satellite data. Strip out all the waves, strip out the swell, wind waves, tides, all that. We're looking for a bulge on the ocean surface. So that's South America there, Central America, New Guinea there, equator, dateline. And we're not seeing it. If anything, we see negative anomalies, -5 centimeter anomalies. So what we're looking for is if there is warm water at depth, warm water expands. When it expands, it creates a little bump on the ocean surface, a 5 centimeter bump, and this satellite could pick that up and give us some hints of that. But it's not seeing any of that, so it's suggesting that, yeah, if anything, the bias is more towards the cool water back here, that big pocket of cool water that we saw way down at depth, that it's contracting, and even though we know there's warm water on top, the net effect is it's pulling the whole ocean surface down in this region, suggesting cool water dominant at depth. That's probably not a particularly good sign. Next up, upper ocean heat anomalies. This is sort of a history of warm water or cool water movement across the Pacific. This is the West Pacific here, East Pacific here. May of last year, Kelvin wave stalled. Cool pool developed off of Ecuador. We thought we were going into La Nina. Second Kelvin wave stalled, never made it east to Ecuador. And then magically in September, well, we probably got a stronger westerly wind burst that gave the warm water more momentum, and we ended up with a Kelvin wave making it the whole way across the Pacific, erupting into Ecuador in the December-January timeframe. Another one of these westerly wind burst that created a Kelvin wave that's semi sort of stalled, but then with a stronger component behind it, and that is right now. Well, part of that erupted back in February. The other part is sitting, trying. It's the bit we saw, the Kelvin wave number 6 trying to push into Ecuador. Not sure that it's going to make it. And there is that cool pool at depth building underneath, and you see, if you look, you really don't see any cool water like that in the past year, and it's probably been almost 2 years since we've seen it. Now, there's a little bit of warm water trying to build in the far West Pacific, but again, there's just no real momentum. We suspect energy, anything towards an El Nino type propensity has just pretty much dissipated, but we're not in a position yet to move into a full-bore La Nina either. All right, so we've looked subsurface. Let's go take a look at the surface. What's going on? Well, this is kind of interesting. In fact, 5 days ago, well, this is South America here, right? Central America. The equator is right along there. There's the Galapagos, Ecuador. And we had a good solid buildup of warm water here. That was Kelvin wave number 6 probably erupting at the surface, and trade sort of backed down a little bit, and it sort of negated any upwelling, and it looked really good. I mean, it looked like El Nino, if anything, but now, today, things have tamped down a little bit. Easterly anomalies on the increase, upwelling on the increase, and a lot of intermixing going on, but still, okay, along Peru, warm water along Peru, a little bit of cool water along the immediate coast, but in general looking pretty good. We had this persistent cool pool that was off here. Well, that's the last of it right there. It's all but gone. There's our warm water from the Galapagos the whole way out to a point just about south of Hawaii. Then this cool pool off of California and Mexico, typical of springtime when you have high pressure, a lot of north winds that creates upwelling and cool anomalies. So at this point in time, doesn't look at all like La Nina. If anything, looks more like El Nino, but kind of late in the year for that. If this was happening in the September-ish time frame, we'd be encouraged. But it's not. It's not even the beginning of summer yet. And then the 7-day trend. All right, there's the equator right there. There's Peru. And what do we see? blue, cooling anomalies, cooling temperatures. Now that doesn't mean cold, just means over the past 7 days, temperatures have been cooling. That's exactly what we saw. 5 days ago, water was really warm out here, starting to back off. This just sort of confirms it. Otherwise, there's no real large-scale areas of warming. It's just 5 degrees north and south of the equator that we're interested in. We don't see anything. It looks like pretty much a neutral temperature pattern, if anything, getting cooler right along the equator in the East Pacific. But the good news is, zoomed out, you see generally warmer temperatures on the equator, along Peru, all that sort of thing. No cool pool off of Peru anymore. The cool pool off of the U.S., if anything, this looks better than normal. It's not neutral. It's a little bit biased warmer than normal and doesn't look like La Nina at all. And if anything, looks a little bit biased towards El Nino, but we know that's just sort of a temporary type situation. So what does the atmosphere think is going on? Well, one way we can measure that is by the Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. When the index is negative, that means that you have lower pressure over Tahiti, and that is biased towards either the active phase of the MJO or El Nino if it's lasting long enough. The daily contribution today 0.94. You want to see this like down at minus 20 plus and holding for 10 to 15 days to be a strong active phase of the MJO. We're nowhere near that, and just looking at the numbers, it's been bouncing all over the place, not trending one way or the other, dead neutral, which is sort of what we're seeing everywhere else, just not a lot of energy in the atmosphere. 30-day average, minus 1.74, and actually rising. We were down to, minus 5.68 there, something like that. Minus 6. Yeah, so if anything, the atmosphere, according to this, is also weakening. And then the 90-day average, minus 3.09. It's about what it's been for a month now. So no change whatsoever. There's no push in the atmosphere to forcefully create storm production. But at the same time, there's no momentum to suppress it either. Just kind of dead neutral. And the 30-day SOI trend, here's where we are today. You can see what it's been the past year, hovering lower than normal. You'd think it's got to be down about minus 15 consistently, maybe minus 12 to be El Nino. So we haven't been there, but definitely not La Nina, not positive. Here was our La Nina little burst back in 2018. Since then, the trend sort of trended down, and now today trending up, but we're still not even at neutral. So again, no real momentum one way or the other. Let's go take a look at the forecast. So here's sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region. If temperatures are positive, half a degree above normal for 5 consecutive months. It's actually 3-month groupings, but we'll just say 5 consecutive months. Then that suggests El Nino. Negative, a half a degree for the same time range, La Nina. All right, so here's where we've been. April 1st right here, 0.7 degrees above normal. Okay, so kind of biased warm. According to this model, major crash is forecast, with temperatures dropping down by July to about minus 0.6, by October down to minus 1 degree, and then hovering there. The good news is this model has consistently been saying that we were going down to minus 1.5, which would have been a major La Nina as we get into fall. Now, there's been a lot of discussion amongst the experts that this model is biased. It doesn't, it's biased cool. It doesn't pick up on certain things, and a bunch of other models have been discounting this, saying we're just going to hover around neutral this winter, or maybe, just below neutral, but not in La Nina territory. It's hard to say. You look at all the models and you go, well, I don't really see a major crash in water temperatures coming, but who knows? We got 2 months. We'll see what happens. And we are in the spring unpredictability barrier right now. The models have a very hard time figuring out what's going to go on with El Nino, La Nina, till you get till about the end of May. So we have another month to go, and then we'll be out of it. But I would suspect some tendency towards negative numbers, but the question is how far deep? 1 degree or just maybe a quarter of a degree? Don't know, but that's the difference between a normal year and a La Nina year, and it's just too early to know for sure. So for now, news is pretty good. Series of small gales forecast for the eastern Gulf of Alaska should make swell pushing into California, and maybe a little bit of sideband energy down into Hawaii. That's good. One small gale forecast moving well to the north and pretty far north in the southern hemi, which could create a southern hemi swell. So certainly not flat. Wind swell, not so much. Kind of a weak pressure gradient for this time of year off California, which is actually kind of a good sign. If we were in La Nina, you would see a lot stronger high pressure off the coast, a lot stronger north winds along California, and we're not seeing that. So just kind of this dead neutral pattern. The big question remains, where are we going as we get into fall? The models, some hinting towards a La Nina pattern, others saying just sort of hanging the way we are. We're in the spring unpredictability barrier. We don't know. Hang on for the next couple of weeks and we'll have a much better picture of what's going on. But for now, short term, it looks like there's more surf on the way. Do your best to, adhere to beach closures, but certainly get some surf if you can. Don't drive far to do it. And don't drive at all if you live next to the beach. That's the best way to go. All right, so that's it. We'll do this again next week. Same time, same channel. Oh, yes, and of course, if you like the video, hit the likes, thumbs up. We appreciate it. Comments, always welcome. We'll reply. And if you haven't subscribed, please subscribe. You'll get an email. And if nothing else, follow along at stormsurf.com. All the data you saw here is presented on the website. All right, thanks for watching. See you next week. Bye.